Hey there, MSM3. Today we are talking about adding and subtracting numbers that are in scientific notation. So, first of all, scientific notation, a large or a small number, where we have something that is between 1 and 10. 1 can be included, 10 cannot, and it's being multiplied by a power of 10. So, the first thing we have to do is figure out how to rewrite numbers that are almost looking like they're in scientific notation, but they're not quite. So this one right now, 67.8, you'll notice is too large. It needs to be a number between 1 and 10. So in order to do that, we actually need to make the 67 smaller, 6.78. And when we make that smaller, what we just did was we took away a power of 10 here, which means we need to compensate by adding a power of 10 to the exponent. So it would be worth the same as 6.78 times 10 to the fifth. The next, if we bring this from 0.9 up to 9.23, what we just did was we increased this value by 1 power of 10. So in order to keep the balance, we have to decrease the exponent by a power of 10. And that's a positive 6 exponent because it was a positive 7 take away 1. And on this one, what you'll notice is 243 is much too large. We have to make this smaller by 2 powers of 10, 2.431. And so if this is smaller by 2 powers of 10, we need to make the exponent bigger by 2 powers of 10. So negative 5 plus 2, more negatives than positives. So it would be times 10 to the negative third. The exponent will increase when you move the decimal to the left. So in this case, I moved my decimal point left, making the 243 smaller. That means I have to have the exponent increase. The exponent will decrease, like our second example, when you move the decimal point to the right. So for example, I moved this to the right one place and made it go up to 9.23. And in order to keep that balance, I had to make the exponent go down by 1. To add and subtract numbers in scientific notation, you have to pay attention to place value. When adding or subtracting numbers in scientific notation, both numbers must be written with the same power of 10 so that you're adding or subtracting the same place value. So this is what's really important here. Both numbers must be written with the same power of 10. It is the same idea as having a common denominator when you add and subtract. Adjust one of the numbers so that both numbers have the same power of 10. It is, again, like getting a common denominator. Moving the decimal to the right will decrease the exponent. Moving the decimal to the left will increase the exponent. And then you add or subtract to the decimal number. Use the common power of 10 with your result from the previous step. Now, I want to put in a little disclaimer here. You want to go up to the higher exponent. It is going to save you, oh my gosh, I'm having a tough time here, exponent. It's going to save you time later to go up to the higher exponent. And I'll show you exactly what I mean by that. 5 times 10 to the third plus 4.1 times 10 to the third. So if I look at those, you will notice that they both have times 10 to the third, which means they already have that kind of common denominator. So I can add the 5 and the 4.1, which is 9.1, and then they keep their common denominator times 10 to the third. Now what's actually happening here, 5 times 10 to the third is 5,000, plus 4.1 times 10 to the third is 4,100. So what we're doing is we're adding numbers that line up, that have the same amount of decimal places, and we get 9,100 or 9.1 times 10 to the third, just as an example. So I just wanted to show you why it works. The next one, you'll notice this one has 10 to the second and 10 to the third. So they do not have the same power. They do not have the same exponent. So I'm going to go up to the higher exponent, which is 10 to the third. So this one is going to stay 2.1 times 10 to the third. This one, however, I want to go up by 1. So if I want the exponent to go up by 1, I need to get this 4.13 smaller by 1 place. So 0.413 times 10 to the third. So purposefully, I changed my 10 to the second to 10 to the third by increasing 1 power of 10. So the number out in the front, the number with the decimal point, I made it smaller by a power of 10. So now I am adding 2.1 and 10 and 0.413, and you'll notice they now both have that matching power of 10. So 2.1 0.513 times 10 to the third. And the reason that my answer is already in scientific notation, 2 between 1 and 10 times the power of 10, is because I went up to the higher exponent. This one has a 10 to the 18th and a 10 to the 20th. So I want to go up to the higher exponent, which is the 10 to the 20th. So that means I want this one, the exponent, to go up by 2, which means I need the decimal place to have this number get smaller by 2 places. So 0.081 times 10 to the 20th. And I'm adding that to 3.2 times 10 to the 20th. So now they have that matching 10 to the 20th. I can add the number that's out in front, 0.081 to the 3.2. And I'm going to get 3.281 times 10 to the 20th. That sort of common denominator, that common power of 10 stays the same when I add them. Now, the last one is subtraction on this page, and it's the same idea. First, I want to look for the power of 10. This one has 10 to the third, and this one has 10 to the third, which is great. That means they're ready to subtract. Pay close attention, right? 9.1 take away 2.3. So when I do that subtraction, if I can do it in my head, great. This one requires regrouping. So 11, 10, 9, 8. 8 take away 2 is 6. So when I subtract, I get 6.8 times 10 to the third. And again, that power of 10 stays the same. All right, on to the back of here. I've got a couple more that is subtraction. We'll do the same thing. First of all, I want to go to the bigger power of 10. So I've got 10 to the negative third and 10 to the negative fifth. Negative third is larger than negative fifth. So I want to get up to the negative third. This one at negative fifth, I need to add 2, right? Because negative 5 plus 2 would get me up to the negative third, which means this 1.2, I want it to be smaller by 2 decimal places. So I've got 3.4 times 10 to the negative third minus 0.012 times 10 to the negative third. So my goal, again, was to get them both to the same base and same power of 10 there, 10 to the negative third. And now I can do the 3.4, take away 0.012, and it is 3.388, still times 10 to the negative third. Last but not least, 3.56 times 10 to the sixth, take away 2.9 times 10 to the fifth, the higher exponent being the sixth. So I want to make the other one go up by 1 so that they'll have the same, meaning that this one needs to get smaller by a power of 10. 3.56 times 10 to the sixth, take away 0.29, now times 10 to the sixth. It's subtraction, just double check that you are doing the right operation and that you don't sort of jump to addition just out of habit. They both have 10 to the sixth. So 3.56 take away 0.29, 3.27 times, and you keep your 10 to the sixth. The last section on here is comparing. So if I'm going to fill in the blank with a greater than, less than, or equal to, I have to have something to compare. So first of all, you want them to look similar. So either both in scientific notation or both out of scientific notation, standard form. I'm going to move this one and say 1.8 times 10 to the negative third. So I'm comparing 1.8 and 1.8, that's the same. This one is 10 to the negative second. This one is 10 to the negative third. Which one is going to be closer to 0? 10 to the negative second is going to be closer to 0, making it the larger one because they are decimals. I'm sorry, I didn't mean closer to 0. The exponent is closer to 0, not the overall number. Just want to clarify. Because if I wrote this one out, 0.018, it is actually larger than 0.0018. So the exponent is closer to 0. All right, just want to clarify. This one, 5.1 times 10 to the fourth, 5.6 times 10 to the fourth. You will notice that they both have times 10 to the fourth. So all we have to do is compare the 5.1 and the 5.6, 5.6 being larger. So common power. That means I just have to compare that number that's out in the front. 4.2 times 10 to the second compared to 6.1 times 10. If you want, one of the things you can do is take the number out of scientific notation. If you do that for both of them, then it's really easy to compare. The other thing you can do is say, well, this one's 10 to the second, this one's just 10, making this one larger. 9.2 times 10 to the negative second, 6.3 times 10 to the negative third. Option number 1, get them so that they have the same power. If I add 1 to the exponent, I have to get smaller by 1 power of 10. Now I'm comparing 10 to the negative second, 10 to the negative second because I added 1. I'm comparing 9.2 and 0.63. The 9.2 is larger. Your other option is to take it out of scientific notation. And this one would have to move 3 places. And you can also compare them in standard notation to know which one's larger. Last but not least, this set, I have to actually do some addition before I can compare. I want to go up to the larger exponent, meaning that this has got to get smaller by 1 power of 10. So 3.2 times 10 to the fourth, 0.113 times 10 to the fourth. Now they have a common power of 10. Add them together. Now they're both 10 to the fourth, right? This one has times 10 to the fourth. This one has times 10 to the fourth. I've got a 4.23 compared to a 3.313, making the first one larger. So lots of different options on this, putting things in scientific notation, putting them in standard form, or just getting them so that they have the same power of 10 so that you can compare.